Hey boys, Mrs. Silva here. We're looking at 10.5 today, trigonometry and area. And please be sure to email me if you're having trouble with any specific areas, and in future videos I can go over those. All right, and we do have a quiz tomorrow. Remember, you can use your notes and your notebook, your book and your notes on the quizzes, not the tests. So make sure you're memorizing these different formulas. All right. So I kind of had already started a different video, and then I've made a mistake, as you can see with my whiteout here. So I thought I would just start again so as not to confuse you. We are going to be using isosceles triangles and trigonometry to find the area of a regular polygon. So let's take a look here. What's the area of a regular pentagon? Of course, that's 5 with 4-inch sides. Round your answer to the nearest square inch. Okay, I went ahead and I drew a pentagon, which isn't half bad for me, is it, guys? And I labeled the side 4 inches. And we got the area of a half AP. And now we're plugging in the perimeter. So the perimeter would be the 5 sides times the 4, which is 20. Hence, before I wrote 25, which is not very good math, is it? But now here comes the problem. We need the apothem. And remember, the apothem is from the middle, perpendicular to one of the sides. So we made a triangle in our last one. And when we did this, we knew that this whole side was 4, so that this little part here was 2. And we had developed a 30, 60, 90 triangle, or possibly 45, 45, 90. I don't know if that came up, actually. I can't remember. And it worked out pretty slick using our x, 2x, and x root 3. But in this case, what we're going to find is when we divide this up into our little triangles, and we think of 360, there's 1, 2, 3, 4, 5, right? There's only 5 angles. So 360 divided by 5 is now 72. So the degree measure here is 72, and when we divide it by 2 to get these inner ones, we get 36. So unfortunately, we cannot use our 30, 60, 90 in this case. But we do know all those trigonometric functions, which is going to help us in this one. So if I need the apothem, and I have this side and I have this angle, which function would I use? That's right, Dan. We're going to use the tangent function. So the opposite of 36 is 2, and the adjacent to 36 is a. Very, very good. So we have the tangent of 36 is equal to the opposite over the adjacent. Now I've got the a on the bottom there. So Jonathan, do you remember how we go about solving that for a? Ultimately, yes, what happens is these two end up switching. So we end up with, because you can flip those and it stays the same. So we end up with a equals 2 divided by the tangent of 36. Yay, we've got our apothem. So we can go over here where I did not leave enough room and plug that in. Make sure you use degree mode on your calculators. Double check to make sure degree mode is in there. I'd like you to go ahead and punch that in on your calculator and let me know when you get an answer. Jeffrey, what'd you get? That's right. Very good, Jeffrey. 28 inches squared. Should have been your final answer. All right, excellent. So let's take a look at the next one. There's 3 examples today to go through. A tabletop has a shape of a regular decagon. Now, who remembers what a decagon has? Very good, Dan. It has 10. With a radius of 9.5, what's the area of the tabletop to the nearest square inch? So let's start off with that formula again, which I have right up here. The area of a regular polygon is 1/2 the apothem times the perimeter. And the perimeter in this case would be what, Jonathan? We're waiting, aren't we, Jonathan? Because the problem is we don't know what one of the sides is, do we? So it's not a simple, okay, 10 times this. That's not right. This is the radius. So we don't have that yet. And the radius of this goes from here, I'm going back up to this picture, to a vertice. Okay, so that's not the radius either. I mean the apothem. So we need to take a look, and we're going to look at just this piece of the triangle. So I'm going to draw just a triangle, kind of, instead of trying to draw a decagon, because you guys can imagine what will happen if Mrs. Silva tries to draw a decagon. This will be our apothem. This will be our radius, which is 9.5. And we don't know this one, do we? So the only thing, right now we can do nothing with that. But we do know it's a decagon, so we can figure this angle out. Remember how we did that up here? We took the degree measure and divided it by the number of sides. And then we took that was one of the bigger angles, and divided it by 2 to get this angle right up on the top. Kind of picturing again, like I pulled it right out of the decagon and wrote it here. All right, now we're talking. We can get either of those now because we have the hypotenuse. So which function would we use to figure out A? Good, Jeffrey. We're going to use the cosine, adjacent over hypotenuse. And what are we going to use for B, Jonathan, if we need to figure out B? The sine. Very good. So we have two different things we're going here. We have the cosine of 18. Sorry about that. Let me get my white out. Cosine of 18 is equal to the adjacent over the hypotenuse. So we can multiply this on both sides, and we get A equals 9.5. Remember to write that first. Cosine of 18. Yay, we got the A. Now we just need the perimeter, and we can't get the perimeter until we get this. And then we got to double it, don't we? Because that's only part of it. We got to double it and then multiply it by 10, because there'll be 10 sides. Okay. So let's take a look at this. We said this was sine. So sine of 18 equals the opposite over the hypotenuse. Similar solving yields 9.5 in the front, sine of 18. But again, we said we need to multiply that by 2, because then that will give me the whole side. So if we multiply that by 2, 9.5 times 2 is what? 19, very good. So we got 19 sine of 18. And that's one of the 10 sides. So we still have to multiply that by another 10 and get 190 sine 18. Notice I don't multiply the sine 18. Since it's multiplied, I can stick with just multiplying that front number. Now I need you to grab your calculators and tell me what you come up with. Be careful. It's all multiplying. It's 1/2 times 9.5 times 18 cosine equals times 190 times 18 sine equals. Go ahead. All right, you should have gotten, hopefully, 265 inches squared. How's my perfect class doing? Did y'all get that? All right, don't doubt it now. You guys, just because you're at home doesn't mean you're not still my perfect class. All right, So let's take a look here at something new that is kind of neat. It kind of basically puts this information, into a more succinct way of thinking about it. If you're given any triangle and you know two of the sides and you know the angle between those two sides, hence side, angle, side. If you know that information, you can get the area of the triangle using this formula. Okay, now in this one, it happens to use 1/2 of B times C times the sine of A. But you could use it for any of these. It could be 1/2 of A times B times the sine of C, right? It's just got to be that included angle. Or it could be 1/2 of A times C times sine of B. So when we look down here at this one, it's area of that triangle, round to the nearest square inch. We look and see, oh great, we have two sides and we have the included angle. We are all set. We can definitely use this. Okay, so we're going to do area of the triangle is equal to 1/2 BC sine A. So remember, the BC can be any two sides, and the A is the angle between them. Okay, so it's 1/2 times the 16 and 10, it doesn't matter which goes in for what, times sine of 34. So again, grab your calculators. I'll give you a second. Plug them in. All right, what'd you get, Dan? Very good, Dan. 45 inches squared. All right, boys, you got this. Let me know if you have any trouble. Bye. God bless.